Hey everyone, welcome to your quad on free energy. As we're doing this particular assignment, keep in mind that we are looking and talking about enzymes and how they change or how they influence reactions by speeding them up. Your enzyme plus your substrate will yield an unstable intermediate known as your enzyme substrate complex. And then at the end of the reaction, the enzyme is free to get used up again, and you are left with some products. So we're going to talk about two types of reactions that occur in the cell, both endergonic and exergonic reactions. Let's start with your exergonic reactions. With exergonic, what you are going to see, we're going to draw a graph, and this is over time, and we have just generic energy here available, or that is involved in this process. With your exergonic reactions, what you see is a net release of energy. In other words, your substrates will have more energy than the products. So I'm just going to use some random examples with numbers. So here's my substrate. Let's say that the substrate had 40 units of energy available to it. The products themselves, let's say, have 10 units. And again, I'm just making these numbers up. So that means there is a difference of 30 between the substrate and the product. Not only is there a difference of 30, but you'll notice that the products have less energy than the substrate did. So in that case, what we would say is that the delta G, the change, that's the Greek letter delta, the change in free energy is a negative value. Excuse me. In these types of reactions, they are typically what are referred to as catabolic. We're going to break something down. But there is an input of energy into this process. And we call that input, we call it the activation energy. That is the amount of energy needed to get this process started. Now what enzymes do is they change that energy of activation. So here's my activation energy. That's that input of energy that we are going to input to get this reaction started. Enzymes will come in and change this energy of activation. Our substrates are still going to start at 40. The product will still end at 10. Enzymes don't change that part. What they change is this energy of activation. So what you'll see here, this dotted line, is our enzyme catalyzed reaction. And notice that the amount of energy that it takes to get over this hump right here is a lot less than it's going to take to get over this hump here. So that input of energy to overcome your energy of activation is also going to consider that the energy to get that enzyme substrate complex going. And then once you have this high energy, very unstable intermediate, it will drive the reaction towards the product. And so with this energy of activation, that is what the enzyme is changing. So when I ask you what does an enzyme do, you tell me it speeds up chemical reactions. But now you must include that it speeds up the chemical reaction by lowering that activation energy. Now, not all of this energy is that change in any of the 30 units of energy is going to be available. Some of it will be. There is going to be some that's lost as heat, but the energy that is released here is now going to be used to drive our endergonic reactions. And that's what we're going to do down here at the bottom. So here's our endergonic, and it's opposite of exergonic. So if we have a net release of energy for exergonic, endergonic is going to be net input of energy. And again, that energy is going to come from the exergonic reactions. Our substrate will have less energy than the products. And so when we look at this graph over time, and again, generic units of energy over here, Let's say our substrate starts with 10 units of energy. Again, making up a total random number. And then our product will have more energy than what we started with. So this graph will look like this. Our delta G is positive. And this is typical of anabolic reactions. So the energy that's released is going to then be, the energy that's released in these reactions is now being input into your endergonic reactions. You're still going to have your substrate product. You'll still have a transition state that's a temporary transition state. And then enzymes again will affect this reaction by lowering that energy of activation. So this is uncatalyzed, that means without the enzyme, and then here's my catalyzed with the enzyme. And so once you reach this high energy intermediate state, you'll see that it's still driving towards the product. There's a release, a little release of energy here, but overall the substrates have less energy than the product, and so you have a positive delta G. Thanks for watching.